So now we are doing number 9. Let's enjoy this number 9. We have a polynomial, blah, 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 blah. And this is a cubic thing, right? And they said it is denoted by P of X. Now, it is given that you can see that it is A and B, things we don't know. So obviously, they'll make us find them. Anyway, let's find out what they want us to do. This is, again, another question from algebra, right? This is another question from algebra, and they've given us a polynomial. It is given that x minus 3 is a factor of P of X. And when the first derivative, blah, 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 is divided, the remainder is whatever. So you are going to convert. When you are doing a math problem and you read such statements, you have to convert them to meaningful mathematical things. They said it is given that x minus 3 is a factor of P of X. This line is mathematical. X minus 3 is a factor of P of X. This is a mathematical statement. We have to convert it to be a meaningful statement in maths. It is going to help us to solve. And this one, the first derivative, blah, 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 is when you divide it by this, the remainder is this. So this is amazing. This is fun. This is good practice of the things you know. Because what do you learn when you do this section of polynomials? You learn 3 things. Number 1 is going to be remainder theorem. Okay? You learn the remainder theorem. Then number 2, you learn the factor theorem. Then number 3, you learn, the factor theorem. Then number 3, you learn polynomial division. So you learn these 3 things. And I want to make you master all 3 of them. Okay? I want you to master all 3 of them. Let's talk about remainder theorem. Okay? I want us to talk about remainder theorem real quick, and then we're going to apply it into this one. So what does the remainder theorem tell you? The remainder theorem is going to tell you what the remainder will be in a function when you divide by a certain thing. So if I divide, the remainder theorem is very straightforward. It's very, very easy. It says if I divide P of X divided by X minus 3, for example, or P of X divided by X plus 5, then remainder, you can say remainder will be, to get the remainder when you divide P of X plus 5 by X plus 5, the remainder will be P of negative 5. Okay? You change the sign on the person that is dividing. So it was an X plus 5. For you to get the remainder, you will put negative 5 into P of X, and you will solve and find an answer. The answer you get is the remainder. So remainder theorem tells you the remainder. When you divide by X plus 5, the remainder, for you to get it, you get P of negative 5. The answer you get will be the remainder. Now, the factor theorem is a special version of the remainder theorem. Are you hearing me? The factor theorem is a special version of the remainder theorem. The factor theorem is, we are just reversing the statements. We know that for me to get the remainder, when I divide a function, let's say if I divide f of x by x minus 3 or x minus 2, for me to get the remainder, I would have said f of 2, and then I would get the remainder. Now, what we are now telling you is vice versa. We are telling you that if f of 2 gives you an answer of 0, what does this mean? It means that you are getting a remainder of 0. Because to get the remainder, remember, you change the sign and you feed that value into the function. Then you are going to be given an answer. That answer will be your remainder. Now, let's say you feed a value and it gives you an answer of 0. It means the remainder is 0. So that thing must be a factor. But remember, there is a sign change there. So for factor theorem, we'll be now saying, my brother, if you put f of negative 3 and you get an answer of 0, this should tell you that x plus 3 is a factor. Remember to change the sign. If f of negative 3 is giving you 0, It means the remainder is 0. Of what? When you divide by x plus 3. Because you put minus 3. If you put minus 3, the factor will be x plus 3. If you put 3, the factor will be x minus 3. You change the sign. So here we are saying f of negative 3 is 0. That means x plus 3 is a factor, which means it is something that divides and gives us a remainder of 0. That's simple. It has to be simple. It can't get any simpler. For polynomial division, this is the third one. We are going to be dividing. And I want you to just remember this formula. Divide, expand, subtract. We call it the DES guy. Polynomial division is called DES. You are going to divide. Then you expand. Then you subtract. Before you divide again, you have to expand and subtract. Are we together? Let's go for the question. The question is testing our knowledge for the factor theorem. The question is testing our knowledge for the remainder theorem. Then we'll see if they want us to do polynomial division. We can't lose marks in an A-level paper to this. Impossible. Surely you can remember. To get the remainder, and if I'm dividing by x plus 5, to get the remainder, I will put in p of negative 5. If I get f of negative 3 being 0, then x plus 3 is a factor. That's the factor theorem. Kind of. Polynomial division is DES. Let's see the question now. Remember, these statements are key. I told you, convert statements to maths. They have said, it is given that x minus 3 is a factor. If x minus 3 is a factor, it means that p of 3 should be equal to 0. Because that's the factor theorem. If p of 3 is 0, then x minus 3 is a factor. So we have been told that x minus 3 is a factor. So we now know that p of 3 has to be equal to 0 because we've been told that this is p of x. So first you're going to write to say, okay, p of x is equal to 6x cubed plus ax squared plus bx plus 9. So now you're going to say, since x minus 3 is a factor, that means p of 3 is equal to 0. Okay? Now let's find it. So what will be my p of 3? P of 3 is equal to, wherever there's x, we're putting 3. 6 by 3 cubed plus a by 3 squared plus b by 3 plus 9, which is going to be 27 times 6. Let's say 27 times 6. This is 162 plus 9a plus 3b plus 9. Now if you say, what is 162 plus 9? You get 171. So this is 171 plus 9a plus 3b. This is our p of 3. Now you can say, let p of 3 be equal to 0. So we are saying now 9a plus 3b plus 171 is equal to 0. Are we together? Then we can make one of them the subject if we so wish to. We can take these two to the other side. We have 9a is equal to negative 171 minus 3b. Okay, then we can say a is equal to negative 171 minus 3b all over 9. There we have our a. There we have it. This is the first equation. Now let's go to the second statement. You got to interpret what it means. This is easy stuff. These are 5 marks at 5 marks. 5. Imagine 5 marks of a P3 A-level maths paper, and you want to lose them? How? Why? Impossible. You can't. It says now, when the first derivative, do you have it? No. Get it. Go ahead and get it. Because they're saying when the first derivative, blah, blah, blah. I can't even hear the rest. First, I got to find the first derivative. I don't have it. Let's find it. So I'm going to say, okay, P of x again. This is just equal to 6x cubed plus ax squared. So it's 6x cubed plus ax squared plus bx plus 9. Then the first derivative of x is going to be, you drop the power, reduce it by 1. 3 by 6, that's 18x squared plus 2ax, okay, plus b. This is going to be the first derivative of x. Can you see this? Now let's go to hear what they're saying. They said, when it is divided by this, the remainder, that's obviously the remainder theorem. That's obviously the remainder theorem, class. That's obviously the remainder theorem. They say the remainder is 72 when you divide p dash x by x minus 3. So we are dividing by x minus 3. So to get the remainder, we would have said p dash of 3. P dash of 3. That's how you get the remainder when you divide by x minus 3. It will be p dash of 3, the positive one. So this is going to be 18 of 3 squared plus 2a by 3 plus b, which is going to be now 18 times 9. That's 162 plus 6a plus b. This is our p dash of 3. And they said since p dash of, or you can say let p dash of 3 be equal to 72. That's what they say. That's the remainder. So the remainder will be now say 162 plus 6a plus b is equal to 72.